So this is another beautiful integral. As you can see, we'll be solving this integral. So okay, this again is just another concept on trigonometric substitution. As you can see, it's the integral of the rad of 1 minus x squared. As a calculus student, you can see this is just a squared minus x squared. Okay, so we'll be solving this. My previous tutorials, we wrote all the 3 formulas of trigonometric substitution. So as you can see, judging from this part, you just see this is just a sine theta substitution. So I'll just choose my x to be a sine of theta, right? From here, the formula for sine usually says it's the integral of the square root of a squared minus x squared dx. So as you can see, this is just the same as that. So I'll just take my a squared to be 1. So a squared is just 1. So my a is just 1. And so on and so on. So from there, I'll just substitute what will be my x. My x will be, what's my a? What's my a? My a is 1, so it's just 1 sine of theta. Okay. From there, I'll just replace my dx. From my dx, I'll get it from here. So it's my dx here. My dx, I'm differentiating x with respect to sine. So I'll just get differentiating sine. This is just a constant. We usually don't write. Differentiating sine, I'll get cos of theta with respect to theta. It's just d theta. Once you have done that, replace back into the integral. So I'll say the integral, okay, of the square root of 1 minus what is x squared. Okay, from x we get our x squared from here. So I'll say my x squared, I'll just square 1. Remember there's a partial 1 here. Square 1 is just 1. Square sine of sine theta, I'll just get my 1 squared multiplied by sine squared of theta. So this is just my x squared is just the same as sine squared of theta. Okay? So replacing all this information inside the integral, again the integral of this rad of 1 minus x squared is just sine. So it will just be minus sine squared of theta, right? Multiplied by my dx. So what's my dx? My dx is cos theta d theta. I'll multiply by cos theta d theta. Okay? So from here, as you can see, there's just a Pythagorean identity here. The Pythagorean identity that usually says cos squared of theta is the same as plus sine squared of theta is the same as 1. Okay? So what is 1 minus sine squared of theta? Take sine squared of theta that side. So I'll get to the right side, I'll get 1 minus sine squared of theta is just the same as cos squared of theta, right? Cos squared of theta, I'll take it to the other side. So I'll get my integral of the square root of cos squared of theta multiplied by cos theta d theta. Okay? So the square root of this, just the second power cancels with the square root above. So I just won't be writing, let me just write. So I'll get the integral of cos theta multiplied by cos theta d theta. As you can see, this is just the same as the integral of cos squared of theta d theta. So how will we evaluate this? There's a video on trigonometric integrals. So we have reached a concept now. Then it will be handling trigonometric integrals, as you can see. So I posted a video on trigonometric integral on how to solve the integral of trigonometric function. So we are told integrate cos squared of theta d theta. In my video, you can check out my video, we usually say this is an even power of cosine. So I'll replace my cos squared with the power reducing formula. So the power reducing formula for cos squared, it's that. So the power reducing formula for cos squared, it's a half into 1 plus cos of 2 theta, right, d theta. Check out my video on trigonometric integrals. You'll be able to compute this, okay? You'll be able to compute this. Check my video on trigonometric integrals. So I'll take my a half outside the integral. So I'll get a half the integral of 1 plus cos of 2 theta d theta, right? I'm integrating 1 with respect to theta, so this is just be my theta. Okay, so I'll get my a half multiplied by, remember a half multiplies all the things inside the bracket, so I'll get my theta, okay, plus from here, from the video on trigonometric integral, you say just integrate cos. When you integrate cos, you get sine, okay. Write the argument the way it is, 2 theta, then divide it by the derivative of the argument. So the derivative of 2 theta is just 2, okay? So this is our answer, then add a constant c, okay? But as you can see, this won't be our final answer. We said 2 multiplies all, remember? As you can see, that won't be our answer. So we'll have to draw a Pythagorean triangle. So the procedure is just the same. We just have to draw a Pythagorean triangle. So let's open up a half. So I'll get a half theta, okay, plus this half multiplied by half, I'll get a quarter. I'll get my a quarter sine of 2 theta plus c, right? That's my supposed answer. Literally, that's the answer. But we'll have to replace our theta and that. Okay? As you can see, again here, from there, this is a double angle formula. This is a double angle formula. I made a video on the double angle formulas, so I'll replace that with the double angle formula for that. So I will say a half, check my video on the double angle formulas, plus a quarter, I'll multiply that whole thing. The double angle formula for sine is 2 sine of theta cos of theta, right? Close the bracket, plus c. Okay, so let's open a quarter, so I'll get a half of theta plus this cancels with this, I'll get my a half of sine of theta cos of theta plus c. Okay, so this is our answer, yes, but we haven't replaced theta, sine of theta, cos of theta, so we'll have to draw our triangle. So let's draw our Pythagorean triangle. In our Pythagorean triangle, this is the right angle. Let me choose my theta to be that. But keep in mind, what was our first assumption? Our first assumption was let x to be 1 sine of theta, right? So using the concepts of SOHCAHTOA, I'll get my sine theta. Let me show this my theta. My sine theta to be opposite. What's the opposite? Here's the opposite, so it will be that one. Remember, there was a partial 1 here, so it's just the same as divide by 1. So it's x divided by 1. My hypotenuse will be 1. Automatically, my b, as you can calculate, is just 1 squared minus x squared, then do the square root. So it's just 1 minus x squared, but now inside a square root. Okay? So from there, we'll have to replace all this information using this part. So I'll say, what was my answer? My answer was, this was my answer, this was my answer. My answer was a half theta, okay, plus a half sine of theta cos of theta plus c, right? So I'll replace my half, my theta from here is just sine inverse of x, as you can see. So I'll get my sine, I'll get my a half, sorry. I'll get my a half. What's my theta? From this part, my theta is sine inverse of x, right? Plus a half. What's my sine theta? My sine theta is x. Okay? It's just x divided by 1, but I won't write that, so I'll just x multiplied by, again here is multiplied by, what's my cos theta? My cos theta from here, it's adjacent divided by hypotenuse. So my cos theta is my adjacent is, so it will be the square root of 1 minus x squared divided by my hypotenuse 1. Okay? So my cos theta is just the same as square root, so it will be multiplying that with the square root of 1 minus x squared. It's simple that way. So most of the trigonometric integrals are long, but okay, I'll just add plus my constancy. So this is my supposed answer. Okay? So this is my final answer, as you can see. So that will be my final answer. So this is example 2 on the trigonometric integrals. Check out the video on the formulas. Check out the video on all the formulas of double angle formula. We have power reducing formula. As you can see, they are important in evaluating this, and we have created a video on that. Again, my WhatsApp number. You can reach me out through my WhatsApp number for more clarity and explaining the videos. This example 2, I'll post another video on this from the University of Nairobi, sample integral questions. I'll be posting in the next video, the third video on how to solve different integrals. And so don't forget to like, share, and subscribe. Thank you.